Hello everyone. So now we will see the editorial for the question ये वो नहीं हो सकता from Convex 2.4. So in this problem you are given an array A of n integers and you are asked to find for every I between 1 to n what is the max of the elements aj such that j is less than or equal to I. That is, you are asked to find what is the max of all elements a1, a2 and so on till ai for all I less than equal to n, right? So let us see an example. So here you are given the array A 4 3 4 5 2. So in this array, first when you consider I equal to 1, you have only this part of the array. So max of 4 is just 4. So for I equal to 1, the answer is 4. Next, when I equal to 2, you have these two elements. So in this case, you are supposed to find max of 4 comma 3, which is 4. Similarly, for I equal to 3, you have this part of the array, and the answer is 4 again here. And for I equal to 4, you have this part of the array, and here it turns out 5 is the maximum element. So the answer is 5. And finally, for I equal to 5, you have the entire array, and the answer is 5 here too. So this is the difficulty of this question is easy, and it is an implementation based question. And it's sort of a DP question. So I have mentioned this here mainly because the theme of the contest Convex 2.4 is dynamic programming, and this is one of the most easiest versions of dynamic programming that you can see. So we will skip the notion of dynamic programming for this question now, and let us see the solution. So for the solution, let us first assume that you have this array 1, 2, 3, 4, 5. So let us say you solve the problem till I equal to 4. That means you answer all queries till I equal to 4. So the query of I equal to 4 means you have to find the maximum of 1, 2, 3, 4, and the answer for this case is 4. So this is already calculated for you. Now let us say you add the fifth element. So you are trying to solve for I equal to 5. So once I add the fifth element, so the array looks something like this. So you want to find the max of 1, 2, 3, 4, 5. But already you have the max of 1 2 3 4 from the previous query when I equal to 4. So now you can find the max of 1 2 3 4 5 by simply taking the max of 1 2 3 4 and compare it with the newly added element 5. As this is already computed, you can get it in order one time as it is already there with you. So now max of 1 2 3 4 5 is nothing but max of 1 2 3 4 and 5. So max of 1 2 3 4 is 4 from the previous query, and now you just compare 4 and 5. So answer here is 5. So let us see the implementation, and the implementation is pretty straightforward too. So you are given t test cases, so this loop runs t times, and for each test case you are given the input, the size of the array n and the array. And now let us say current maximum stores whatever is the maximum till the current query. So initially you have an empty array. So let us assume that the current maximum is some value which cannot be a maximum anytime, just for safety. So that so in this case the array has only positive elements. So this is a safe value to put. So now when I run the loop over n, so I first in the first case I get just a of 1 when I equal to 1. So max of a of 1 and current max will always be a of 1. And so that's why the answer in the case of I equal to 1 is always a1, right? Because there is only one element. Now if I keep going further for a later I, for I greater than 1, so I have the value of current max which stores the maximum till I minus 1. So what is the maximum for all elements from 1 to I minus 1? I have that stored at current max. So now what I have to do is just compare A of I with current max and just store the max of those two to current max and print it. That's it.